Okay, so we can solve a quadratic equation by graphing. I've given you an equation in vertex form. We're going to graph each side of the equation, or close to vertex form, this isn't exactly. So I'm going to take negative x plus 3 squared and set it equal, say f of x equals negative the quantity of x plus 3 squared. And then I'm going to take the other side and call that h of x equals negative 4. And we're going to graph that. This is a way to solve this quadratic through graphing. So let's review. We're going to graph this vertex. Blake, what is the vertex? Very good. Negative 3 and 0. There's nothing outside of here, so it's a plus a 0 there. So I'm going to go graph that vertex where x is negative 3 and y is 0. Maddie, what is the a value? What is it? Negative 1. Very good. So remember, we use our patterned rate of change, which is a over 1, then 3a over 1, then 5a over 1. So this, I'm going to go down 1 and to the right 1, down 1 to the left 1. Then next, I'm going to go down 1, 2, 3 into the right 1, then down 1, 2, 3 into the left 1. I can't do 5, so I'm just going to leave it like that. And I'm going to try and graph my parabola as accurately as I can. And that's the parabola. Now I'm going to graph h of x equals negative 4. Okay, this is going to be a horizontal line. So I'm going to go where y. This is like y equals negative 4. So I'm going to go where y is negative 4, which is right here. And I'm going to draw a horizontal line because that's where y is always negative 4. Now, after I've done that, I want to find where f of x equals h of x. Where do those two lines intersect? It's going to be an ordered pair. So let's first, how many solutions are there? How many times do they intersect each other? Twice, right? Okay, what's the ordered pair here? Negative 5 and negative 4. Good. And then this one? Negative 1 and negative 4. So those are the solutions to that systems of equations. Any questions? We're all good? Okay, we can do that over here as well. But this is a little bit more difficult because this isn't in vertex form. So it takes more work for me to write it in vertex form and then graph it. So we're going to use Desmos for this. Now your equation is different than mine, so can you change yours, cross out the equation that you have on your paper, because that one doesn't work as nice as this one will. Okay, and write this down. X squared plus 6x plus 8 equals 3. Again, write down that equation for me. And we're going to graph f of x equals x squared plus 6x plus 8. And then h of x equals 3. Any questions over that? Okay, so we're gonna go to our Desmos. Sorry. I'm gonna type this in. Okay, you have this little keyboard right here that you can pull up and enter X. This is squared. Why does it keep doing that? Squared, oh, delete that. Okay, that's hilarious right now, so let's fix this. Okay, X squared, then plus, is it 6X plus 8? And it graphs the parabola for us. Isn't that nice? Okay, and you can zoom in if you want to see a little closer. Then you're going to touch on the number 2. You want to write the second equation and enter y equals 3. And I'll graph that for you. Does that make sense? Okay, you guys can graph that on your notes. You can see the vertex is at, let's see, looks like -1 and -1, sorry, -1, 2, 3, -3, -1. Okay, so this is my parabola. And then I have 3 right here. So I graph that. If you're struggling to do this, just go back to your Desmos. And it's really nice because you can just touch on the intersection and it'll give you where they intersect. It'll give you the answer, -1 and 3. And then -5 and 3. So those are 2 solutions to that quadratic equation. So I go back over here and I write down my answers. -1 and 3 for y. And -5 and 3. Any questions over that? Then we do the next one. Okay, same thing, we're gonna graph that on Desmos because that makes life a lot easier. I want you guys to change, let's see, mine's a little different than yours. Make the 5 a positive on yours. Yeah, change the x squared minus 6x, put it as +5 instead of -5. Again, it makes it a little easier. Okay, so now I have my solutions there. I have 5 and 0 and 1 and 0. Any questions over that? Okay, so in here, let me graph 5 and 0 and 1 and 0. And then my vertex was down here at 3 and -4. So this is what my parabola looks like. And then the equals 0 is just right here on the x-axis. So my solutions were at 5 and 0 and 1 and 0. Pretty easy, right? Okay, so now in example C, I want you guys to all write this down. What key feature of the graph did the solutions end up being? So from last chapter, what key feature? Any ideas? What are some of the key features we looked at last chapter? The things did we have to find? Yep. They're x-intercepts, right? Okay, so the last one ended up being the x-intercepts. That's exactly what we're looking for. Okay, the solution to a quadratic equation or the solutions to a quadratic equation are the x-intercepts. Any questions over that? Okay, so when we're solving a quadratic equation, what we're looking for are the x-intercepts. Okay, the zero product property is if two factors are equal to 0, then one or both factors are 0. So we have something like this: x plus 7 times x minus 3 equals 0. X plus 7 is a factor, x minus 3 is a factor. What it's saying is that one of these factors has to be equal to 0 in order for it to be equal to 0, because 0 times a number is going to be 0. Any questions over that? Okay, intercept form of a quadratic equation is what we know as factored form. Last chapter, we talked about this, the 3 different forms of a quadratic equation. In factored form, it was very easy to identify the x-intercepts. In vertex form, what was it easy to identify, class? The vertex, right? Because it's called vertex form. Does anyone remember what was easy to identify in standard form? The y-intercept. Any questions over that? Okay. Okay, now in math, it's not confusing enough. Okay, so we want to make it a little bit more confusing. So we have lots of different names for the same thing. So I need you guys to know all of these names so you're not confused as to what they're asking you to do. Other names for the solutions of a quadratic function. So when they're asking you to solve a quadratic equation, they can also ask you to find the roots. They can ask you to find the zeros. They can ask you to find the x-intercepts. They can also just ask you to solve. Those are all the different words that they'll use to do the same exact thing, ask you to solve the quadratic equation. Any questions over that? We're all good? Okay, so we're going to find the roots here. So now instead of graphing it, we're going to show you how to do it algebraically. Okay, we're going to start by just showing you how to factor it. So that's the first way you can solve a quadratic equation, or sorry, the second way. We learned one is to graph it. The second way is to factor it. So if you don't have a graphing calculator or you're not good at graphing, then you're going to try and factor it. So the first thing is you're looking for the x-intercepts. So you have to set it equal to 0 because f of x is 0 or y is 0 when you're on the x-axis. So plug in 0 for f of x. So x squared minus 10x minus 24. We're going to get x squared minus 10x minus 24. And we're going to factor it. So x and x. Okay, well, it multiplies to 24. Okay. People said 6 and 4. Let's try 6 and 4. And I also heard 12 and 2, so let's see which one works. Okay, should I be adding 4 and 6 to get 10? Or should I be subtracting 4 and 6 to get 10? This is a negative. That means only one of them can be negative, not both of them. Okay, so negative 4 and 6 is not going to give me negative 10. So I have to try a different factor. So let's try 12 and 2. So this gives me 12x, this gives me 2x. Now, these I'm going to be subtracting. Which one needs to be negative, the 12 or the 2? 12, good. If the 12 is negative, then this is negative. The 2 is positive, then this is positive. So now I've had my factors of x plus 2 times x minus 12 equaling 0. To solve this, I'm going to use the zero product property. That means that one of these two factors has to be equal to 0. So we're going to separate my two factors and set them equal to 0. And then I'm going to solve. Subtract 2 from both sides, and I'm going to get x equals negative 2. I'm going to add 12 to both sides. I'm going to get x equals 12. Okay. It asked me to find the roots. So we're going to say the roots are -2 and 12. Any questions? Okay, next one. Okay, find the solutions. So we're going to solve this. Okay, it's the same idea, just going to say it in a different way. You're still going to try and factor it. Before you can factor, you need to set it equal to 0. Right now it's equal to 12. So how do I get rid of the 12? Adam, how would I get rid of that 12? Okay, it's already being added, so what I do? Very the opposite. So to get rid of 12, I'm going to subtract it. If I do it to one side, I have to do it to the other side. So I have 3x squared minus 16x minus 12. None of those are like terms, so I just stick them all next to each other. And it equals 12 minus 12 is 0. So now it's equal to 0. Then we're going to factor it. Okay, so we're going to factor this. This is 3x and x. And then 4 and 3. 4x, this is 9x. Does that give me 16? No. If I switch it, 4, oh, I can't put the 3 there. So it's 2. So 2 and 6. This gives me 2x. This gives me 18x. I am subtracting. So to get negative 16, I need the 18 to be negative and the 2 to be positive. That makes this 6 negative and this 2 positive. So my factors are x minus 6 times 3x plus 2. So we're going to separate our factors and set them equal to 0. So x minus 6 equals 0. And then 3x plus 2 equals 0. So I add 6 to both sides. And I get x equals 6. I subtract 2 from both sides. And I get 3x equals negative 2. How do I get rid of the 3? Divide by 3. It's being multiplied, so I divide by 3. So what is this asking me to find? The solutions. The solutions are 6 and negative 2 over 3. Any questions over that? Okay, next one. Okay, I'm going to have you guys do this one in your pairs. Yeah? Oh, yeah. No problem. You're welcome. So everyone does A, B, C, D, F, G, H on your own, in your pairs, I mean. Work together.